welcome back to another video. I'm going to be continuing on with the kind of debugging symbols series of videos that I've been working on. So I'm working on writing a little tool in a language called porth, which is made by a YouTuber, and there's description links in the description on where it is. I've closed the tab, but here's the source code for it. And what I'm doing is basically working through this bug here where I'm wanting to get debugging symbols, some debugging symbols into the source code. So to do this, I'm working through this flat assembler. So I'm using fasm as my assembler, and I'm working through this to basically parse the debug file. So we have a test.asm, so this is a very small assembly file with basically two functions, foo and main, and I want to be able to get out these names foo and main, and generate some sort of another elf file that I can then include in the kernel to basically give those strings that I need. It'll basically make debugging quite a bit easier as the project gets larger. So we've got something going at the moment. So if we look at debug.porth, we basically in the last episode we defined this kind of header structure with all the different things, and had a way to read the header and kind of verify the signature is correct, and we also were able to dump it. So this episode, and that is just the kind of main file, and if we run it against the debug file from that output, we can see that it has dumped the header. It used the 1.73, which is one of the later releases. Doesn't show the kind of patch version of it, but that's fine because patch version probably won't change the header of this that much. Here we have like some offsets, so basically a bunch of stuff. In this video I am looking at kind of finding a strings table and parsing it, and seeing what information we can get out of that and whether it will be useful for us. So I guess without further ado, let's kind of read it. So what I might do is just have a look at this. So at this point we've kind of read 64 bytes into the file to read the header, which we test in the header function. My thought process at the moment is I can see the strings table starts at 64, which is good because that means we don't need to kind of seek in the file. We can kind of just read the header and read the strings. But I am also wondering whether to just make a seek file anyway. So if we look at the porth standard, no, it's in a different place now, Linux. So we have like a read, so this read here. So what we want to do is basically make a, no, not there, we want to go here. So we want to make like a inline proc lseek, because lseek doesn't actually exist as a syscall yet. So we will make it ourselves. Stop doing that and go that way. So let's have a look at what lseek is. It's 3 arguments, so it's going to be syscall 3, very similar to this read. So we'll take an int, a pointer, and an int, I guess, and we'll return an int, and it's going to be in sysl_seek and syscall3, and we missed something. Yeah, it is just meant to be an int there. And we'll have a look at this again. So this isn't actually quite the same. If we look at what read is, so this was integer, then a pointer, then an int, whereas lseek is integer, then kind of an integer, and an integer. It's an integer in porthland, and it's going to return us a integer. So we'll just update this signature appropriately. And I believe the syscall3 will just not care what it is, but we'll need it for typing to kind of pass in what it is. Another thing we'll need is this whence, which could be seek, set, cur, or end. If we go into here, yeah, so we don't actually have any. Well, if we do something like that, we don't actually have that. Cool. So what we might do is reset that. Yeah. So what I'm going to do is kind of get the stuff out. So lseek. What does that need? It needs type and unested. So include one failing at things. So let's just type specific. Let's have a look at that. Yeah, it's just type and unested. Do that unested h lseek. So what I kind of want to do is just print out these three macros, which I could look up in the source code, but I'll just do it like that. Can we do that? Yeah. Cool. It's not valid code, but we'll actually no, I'll make a little macro for this. I'm sure we'll do it on printf, and what are we going to do? We're going to do a net, and that's going to be equal to that. What I might do actually is just make I think this should still work. I'm doing quite a lot of weird jumps in the middle of a macro, but I think it'll still work. And at which point here we actually want to go back here and get that word, and then go to the end and then paste it. Yeah. And if we go back there and go there, and that was on I, that kind of worked. Keep doing the wrong one. Yeah, we need we want stdio Yep. So now if we just see that and not that run that. I had a feeling it would just be these, but what we'll do is basically put those in here. No, we did that. Cool. And we'll just open So now we have a way to basically seek from a file descriptor. So we want to do the width, the offset, and the file descriptor. So what we can do as a wee little test is kind of repeat this code. So theoretically this should fail. So if we do this, Henry failed the second time round. So what we're going to do is fix this first to do. So we want to lseek and I forget the order, but we'll in fact, yeah, it's going to be like that. Cool. So seek so we want to seek set. We want to set it to 0, and we're going to do it on the file descriptor. So we'll seek it to set. The offset's going to be that 0, and we're going to set it on that. So I think that is what we want to do. And if we do that again, right? So it doesn't like that because that returns a offset. Return. Right, returns the offset. And if it's an error, then it's going to be -1. So what we could do is less than 0 if so if we couldn't set for some reason, we'll drop false, and we don't really care other than that. So yeah, and then we only want to do this if we do it alright, so this I think will yep. So if we seek, then we do it, and we'll check that return code and update that, and then we'll basically check the thing, check the magic. So now, yep, cool. I've screwed something up. So that less than which line was it on? 58. That's just the ordering. Concatenated for Polish, reverse Polish notation, so you're going to put that 0 first and then the operator afterwards. Cool, so now we have read the header twice. And it didn't fail the second time, which is kind of what we want. So now if we read strings, in fact we'll just yeah, so the strings were like just a a string table contains just a sequence of ASCII's null terminated strings basically. So what we want to do is basically read the length of it at the offset. So I don't know, we'll make a thing, read strings. It's going to take that file descriptor, let file descriptor in, and we're not going to return anything, I've decided. So what we're going to do first is going to seek to header of header dot string tab, and if we fail, I guess we'll return a boolean just to say whether we were able to do it. And if we were able to do it, what we want to do is we kind of want to have a int pointer. Ooh, I think in that order. And I think we want to do that. So int pointers, how a string is done in porth is it basically pushes the length of the string and then the string buffer, which is kind of what we want to do here. We want to have a memory for the buffer, which so porth doesn't really have like dynamic memory. One thing I did in where have I got it? So if we go, what are we up to? 9. This one. I did actually do it in Advent of Code last year, and one of the things I did there was I made a malloc. So I needed dynamic memory for various things. I don't think it's kind of needed for this. I might just have a kind of just buffer, fixed length buffer of I don't know, like 50k of memory. That should be enough for a bunch of strings maybe, and we'll have that as just like a buffer. I might actually just do strcab for that. And what we want to do now is we want to kind of read. So we were able to seek. And I mean, I'm just thinking the return value returns where we got to as well. I wonder whether we should double check that it is that, but we're checking for -1, and I feel like that is probably enough. If things fail, things fail. It's not the end of the world. Yep, so at this point here, we want to, and I guess if we've got that buffer, we don't really need that. So we're just going to return true or false whether we were able to read stuff. So now we want to do a sweet read, and we only want to read header dot len of strtab, and we want to read into strtab, and we want to read from the file descriptor, and we also want to make sure we got everything. Strtab, yeah. So if we didn't read the whole string table, we want to actually say, nah, we didn't get there. And at this point here, we have read the strings. And string table read failed. I might actually do like eputs here. And that panic can be an eputs. And panic. I actually wonder. Yeah, I might change what panic does. Eputs to do that, and panic will just take a pointer. And yep. Yep, cool. That's fine. What line was that? 98. In fact, I might. Because we read into this memory, like we just, it exists. I might all of these not actually have that pointer to start with. And here we'll just load from that memory that we already had. Yep, and kind of yeah, makes it slightly less verbose. Right. Yep. 15. Yeah. So, we did need that between these two. So it needs to be defined after this, but before this, because that's just how it goes. So we can still read stuff, and theoretically we read the strings, I think. So dump strings, I guess. So it's just a bunch of null terminated ASCII strings. And some strings have kind of like a offset into it. So what we will do is dump strings, and we won't take anything, and we'll that's what we'll do. So at this point here, we kind of need to I might just strings. So at this point here, we have our string table, str tab, and we also have how much we should be loading. So we kind of want to do a loop here. Every time we encounter a null character, we basically want to print out the previous string showing at the offset that we started at. yeah, so what we might do is we want to start at 0. And we want to have kind of a code. Yeah, and we'll assign these to names just to make the code a bit easier. So we'll have last and current. And they're going to be indexes into this table here. We didn't want an in there, we wanted an in and end there. And so what we want to do is now we kind of want to loop. Make sure that the last byte should be null byte, which I guess we can kind of confirm somewhere, but we won't. We'll just go through. So what we want to do is loop through, starting from 0, but we want to kind of keep track of where our last start point was, because that's going to be our string. Yeah, I might not do the end things here, and I might do the old-fashioned porth way of kind of doing it like that. Yes. And what we want to do is while dupe is less than header.len str tab, except that less than should be there. We want to do some stuff. Right, so that's testing whether the current character is less than that, and we'll probably want to do increment at the end of that, otherwise it will just be an endless loop. Always fun. At which point here we want to get that str tab, and we want to get that current thing. We want to read a byte, and if it's null, we do something, and if it's not, we just increment. So really what we're caring about is if it is null. And if it is null, what we want to do is work out the length. So that should be cur minus last, and that's going to be work out start of string, and that's going to be str tab of last. That was going to be like a pointer to that. These comments will go away, but they're kind of just helping me think. And then we want to update last. Yeah, so in that case, and cool. So at this point here, we've got a null byte. So to work out, we want to print it out. So on the stack at the moment, we should just still have last and current. So if we get that last, that's going to be our index. So idx maybe we'll do something like that. And over and put you, yeah, that's the one. And then close that off and put. Alright, so that's gonna like kind of print a little index over where we want, and now we want to over. So it's kind of getting both of them over. So we've got last cur and last cur. And we want to work out what current minus last is. So I think we would go swap and minus. I believe that is what we want. What we could do is quickly here is, I don't know, 5 minus 3 and print and 1 exit. If we do that, we should get 2 hopefully. No, we get type errors 109. What we might do is just comment out that stuff, and we still have stuff. I think I know the reason for that. Drop. We'll want to drop off those 2 things. But anyway, I'll do that. Statically type. Cool. So we got 2. So what we learned from that was the order that this has to be. So we want current minus last. So we want current last then minus. Current minus then last. So yeah, we do want to swap that. Current last then minus. So we want to swap it to minus. So now we've got the string. Actually, we kind of, yeah, I might do this. The joys of stack-based stuff. So we do that, and then we kind of get current minus last. And the reason why I want to do that is now we need to swap that last over there, and then str tab and plus pointer. So before I've used pointer plus, which basically means the pointer to the start comes first and then the offset comes after, but in this case it is the other way around because we're wanting to add that. I could do a swap and then do that, but this should get last like that. So this here is now a valid string that we can just put, and now we want to probably do a new line. Maybe we'll do that up there, and now we want to update the current last. So what we can do is swap drop dupe. So what that will do is it'll put last there, and then it'll drop the old last, and then it'll basically duplicate the current bit. It'll set the last to be that. Except I guess we want to we kind of want to add one to it because we're currently on a null byte. But then in theory we should do 1 minus after the dupe because we're going to add 1 to the current thing on the end. Cool, so I think that will do it. Let's see. Right, So we're trying to read from an int apparently at 109. That just means we need to go a pointer plus. We actually need to load up where it is. Cool, so here we have our header and our strings. And so we can see that we've got test.asm. I might drop the IDX. I think it is obvious with the square brackets. So at 0 we have test.asm and at 9 we have test.o. And if we look up here, offset of the input file name in the strings table is 0, which matches with that, and of the output file name is 9, which matches that. And here we have dot text. Now, I guess let's have a look at what our test file here has. So we basically have the input file name, the test.asm, the output file name, and this text here. What I notice is not in the strings table these symbol names, which is kind of my entire goal of this tool, but that's alright. We will make do. What I might do is kind of clean this up, because the language does have like kind of cool ways to do stuff. So it's got like let and peak, and I think we want to do peak and last cur here, and we want to check whether the current is less than that, and yeah, and we don't actually need the last. So that's basically looking at the topmost thing, assigning a name to it basically. And here we can do last cur in, and the let undo that one. The let will basically take off what was there, and what we can do is else we can just have last and cur 1 plus, and in this case we can have cur 1 plus, and I'll just do that. And here we are reading the current byte, and we are outputting the last, and here we can get rid of like all that stuff. So that was cur last minus, and so that's the length, and we can do str tab of last, and we can favor the pointer plus. Yeah, I think that should do the trick, and what we can do is just still gets the same output. I think that just kind of looks a bit cleaner, that you don't have like lots of overs and swaps and stuff, and you have to kind of know in your head what everything means and stuff like that. And we can probably put that on one line. nice. Right, so that's our dump strings. So what I might do is add that stuff in. Debug. So add string table dump to debug tool. Fasm debug tool. Yeah, cool. That's an alright message, I guess. I'll push that up. So I guess the next step is looking at these section names. Not section names. Maybe the symbols. So I guess we could like work through and figure out where we get our foo and main from, because that's what I'm wanting to get. My whole point of this is getting that foo and main. So I guess the next structure is the symbol table, which has like a bunch of stuff, which I don't know. It's got like a value of symbol, but I think that is probably just the. I guess what we could do is, yeah, I don't know. It's been 40 minutes, so I guess this is potentially a good time to stop the video, and I'll do another video on the symbol table, and hopefully that is what we're looking for. Otherwise, it might be. Yeah, the symbol table, I believe, is just kind of an address of where it is, but we want like the actual name of the symbol. Which it doesn't seem obvious that it kind of has that. It's also, yeah, I don't know, it's got like a few different things we can do, but I'm liking the idea of just kind of working down through this file. I mean, it's not too long, 500 lines, and we've already kind of parsed quite a bit. I mean, the tables take up quite a lot of space, so we've already gone like, I don't know, what would we do? Strings. So we basically got up to 60 lines of that. Yeah, so I guess, I think I'll leave it here, and next video we'll look into, I pushed that. Next video we'll look into the symbols table, and hopefully we'll get that foo and main, because that's what I'm after. That's what I want. And yeah, I am keen to get that because it'll make life easier. But yeah, I'll leave it there. Thank you for watching, and if you enjoyed it or have any feedback, then let me know. And otherwise, we'll see you next time. Have a good day.